All right, in this example, we've got Mr. Gr12 standing on the school. That's Mr. Gr12 there. I don't know, my body sort of disappeared for some reason. There's Mr. Gr12, there's Mr. Jack. You can see how tall he is. Mr. Gr12, let's see, throws a chemistry textbook. Of course, it's chemistry. Textbook straight up, 12 meters per second. Okay, so that's gonna be right here. Let's say there's position 1. That's when it's like in my hand or just leaving my hand. Throws it up at 12 meters per second. It's going to reach some max height, but on the way down, it just misses the edge of the school and then lands in a crumpled heap of detritus. That's like garbage or refuse or whatever. The school's 10 meters high, so let's get a little 10 meters in here. Find the max height above the ground, so from here to here, find the velocity down here at impact. Okay, so we've got a couple positions that we want to consider in this question. Position 1 is, I'm going to assume it's right at the level of the school because I'm pretty short. So when I throw this thing, position 1 is like right at the height of the school. Position 2 is up here at max height, and that's kind of where we're going for part A. Position 3 then would be down here at impact. That's for the velocity at impact. We could look at other positions. We could say what's happening here when it reaches the height of the school again or something, but I don't think we need it. Couple things to notice then is anytime we're going to start to, think of like what's V1 and V2 and that kind of thing, we need to pick what positions we're looking at. If position 1 and position 2 are here, then V1 obviously is here, V2 is here. If we said V1 is here, or position 1 is here, position 2 is here, then V1 is here, V2 is here. We have to consider what interval we're looking at. So for part A, to find the max height above the ground, I'm going to go from position 1 to position 2. Okay, so that's my interval. So forget about anything that's going on down here, on the ground. Let's just look at what's going on here and what's going on up here. So if that's true, then I can say V1, chemistry textbook leaves my hand, 12 meters per second. It's going upwards. Let's say up is positive. Let's say it over here. Up is positive. So 12 meters per second. We could say up or just positive 12 meters per second. Something we know always with these acceleration questions, acceleration is 9.8 meters per second squared. That's down. So again, either we say down or we say negative. Don't say negative down. That actually means up. Acceleration due to gravity is always going to be down. When we reach max height, something that we could say then is V2 is 0. So the reason it has stopped going up and it starts to fall back down is because it stops. It actually reaches a velocity of 0. And what we're looking for is what is the max height. What I can find out of this is between position 1 and 2, I can find out that displacement. Now just keep in mind that displacement is from here to here. What I'm actually asked for is the max height above the ground. So whatever I find here, I need to add this 10 meters to it. Okay, so just keep that in mind. To go through and do this then, we know, let's see, V2 squared equals V1 squared plus 2AD. We can use this equation, that's a good one. We can sub in our information. Just keep in mind those signs, okay? So don't forget, we gotta do those signs, positive or negative signs. Okay, so V2 is 0. Again, 0 squared is just 0, so 0 is fine. This is gonna be 12, that's squared. Acceleration, I'm going to say negative 9.8, and just a reminder, up is positive, acceleration is down, it goes in as a negative. D, I don't know what D is. That's what we're going to find out. Now what we're going to do is figure this out. Let's see, okay, so 2 times 9.8, we're going to bring this over here, so I'm going to say that is 19.6 D. Okay, so 2 times 9.8 is 19.6. It's negative on this side, becomes positive on that side. 12 squared, 144. We can divide both sides. And D is, what is that? 7.35 meters. Just keep in mind, that's above the roof, above the school, something like that. What I want is above the ground. So I'm going to add this 10 meters to it. So let's say max height. H max or something like that is 10 plus 7.35. Let's call it H max. So 17.35. If we do some sig digs, we would say it's about 17, approximately 17 meters. 17.35, of course, but for sig digs, Whenever, just a quick note on sig digs, we're going to pretend always that there's like a decimal at the end of any number. So that's 2 sig digs. Because of the decimal, we'll take that as 2 sig digs. I'll keep 2 sig digs. That's how we'll handle our sig digs in grade 12 physics. For part B, then we're looking for velocity at impact. So I can't use from 1 to 2 information anymore. I've got to include 3. I do have a choice though. I could either go from 1 to 3 or I could go from 2 to 3. Either one is fine. I'm going to go from 1 to 3. And the reason is I just wanted to show you if I had this exact question, but I wasn't asked part A, if I was only asked part B, then I would just go from 1 to 3. I don't need to stop at that middle position. I don't need to kind of do this work to figure out, you know, what that max height there is and then go from 2 to 3. I don't need to do it in multiple steps. So I never had to do this part in order to answer part B of the question. So again, from 1 to 3, V1 then, still 12 meters per second, that's up. Acceleration due to gravity, always 9.8, down. V2 no longer 0. V2 is question mark. That's what we're looking for. What is V2, you know, at impact? That's how fast is it going when it hits the ground? Quick thing, common misconception. Sometimes people think their quick answer is, it hits the ground and comes to rest. So V2 down here is 0. That is not true. It does hit the ground and come to rest eventually, but what we're talking about when we talk about velocity at impact is how fast is it going, like the instant before it hits the ground, or as it makes contact with the ground, how fast is it going? Okay, so that's unknown. We don't know what that is. We do know from here to here, we do know the displacement, or the distance that it's going to go. We're going to do displacement. Everything here really is vectors that we're doing, all these things here. I do know the displacement. Take a quick second, think about it. What is it? Is it 17 meters? Is it 10 meters? Is it 7 meters? What is it? Here's my answer. From 1 to 3, if I start here and go straight down and end here, it's 10 meters. And don't forget, it is 10 meters down. Okay, the book starts here at this height. It ends down here, kind of at the ground, so end is down here. I know that it spends part of its time going up and, you know, more of its time coming down, but just from start to end, the displacement is this. Okay, so 10 meters down, that negative sign that down is going to give us is important when we solve this question. I'm looking for V2. Looks like the same equation. We could do that equation. There are other ways that we could do it, but let's use that same equation. And the only reason I hesitate a little bit is because we're going to end up taking a square root, we do need to think through this answer. So let's go ahead and do it, and you can sort of think through the answer as I do it. V2 is unknown. V1 is 12. Again, that's up, it's positive, it's squared. Acceleration is down, that's negative. Displacement, also down, also negative. Okay, so that's the negative sign I was talking about. It's important that we get that in. Working out these numbers, this is 144. This ends up being plus, right? The two negatives cancel. 196. V2 squared, 340. You don't have to show me as much math as this, but I wanted to make this clear. V2, when I do this, there really is a plus or a minus in here. Okay, so the answer that I get out of this thing is plus or minus 18.4 meters per second. Really, when I'm doing this question, my direction that I've chosen as positive is up. Okay, so I actually want the negative answer. So this is one of these cases where I would say it's negative 18.4 up. We wouldn't write an answer like this, and I'll do sig digs here at the same time. It's approximately 18 meters per second. Negative up is positive down. There's my vector, and let me just make sure you can see that. Yep. So we need to make sure when we're doing this, your first answer, whenever you come up with a vector, your first answer is in the direction you've chosen as positive. When you get that answer, in this case, we actually want the negative answer because we know that the book is going down as it hits the ground. So I need my down answer. I need my negative up or down answer.